Good evening, students. I am Reshma C., Assistant Professor, Department of Civil Engineering, SNIT, Adur. Today, we are going to deal with a topic that comes in the subject CE 304 Design of Concrete Structures 2, which belongs to the 6th semester KTU Civil Engineering branch. Today's topic for discussion comes under 6th module, and the topic is Basic Concepts of Prestressing. Prestressing is the initial application of stresses to a concrete structural member to counteract the undesirable stresses caused due to working loads. Prestressing is commonly introduced by tensioning the steel reinforcement. Three concepts may be applied to explain and analyze the basic behavior of prestressed concrete. These concepts are: first one, stress concept; second one, strength concept; and the last one, load balancing concept. Stress concept. This concept is credited to E. Fressinet, who visualized pre-stress concrete as essentially concrete which is transformed from a brittle material into an elastic one by pre-compression given to it. If an ordinary concrete is subjected to only compressive stresses, it behaves as a perfect elastic material because no tension cracks are there. But if it is subjected to flexural stresses, some portion of it will be in tension, resulting in tension cracks. The material under such circumstances no longer remains elastic. In pre-stressed concrete, tensile stresses caused due to external loads are counteracted by the compressive stresses due to pre-stress, with the result that final stresses in the extreme fiber is either compressive or zero. Due to the absence of tensile stresses, no tension cracks would develop in the member. To illustrate this concept, consider two cases. Case A, stress distribution due to concentric tension, that is, the center of gravity of steel and concrete coincides in this case. A beam is simply supported over a span of L subjected to a UDL of WL per unit length and self weight of WD per unit length. The final pre-stressing force is P. The cross section of beam is shown in first figure. The second figure represents the compressive stress due to pre-stressing force, which is P by A and is compressive in nature. The third figure shows the stress due to MD, which is MD by Z. It is compressive at the top and tensile at the bottom. And the fourth figure represents stress due to ML, which is ML by Z. It is compressive at top and tensile at bottom. And the last figure shows the resultant stress diagram. The net stress on the top fiber and bottom fiber is depicted in it. Both are compressive in nature. Next, case B, stress distribution due to eccentric tension. Here, center of gravity of steel and concrete are not the same. The beam is pre-stressed with an effective pre-stressing force P at an eccentricity E with respect to centroidal axis of the beam. The cross-section of beam is shown in first figure. Second figure represents the direct stress due to pre-stressing force, which is P by A, and it is compressive in nature. Third figure shows the stress due to eccentricity of pre-stressing force, which is PE by Z. It is tensile at the top and compressive at the bottom. The fourth and fifth figures represents the stress due to MD and ML, which are MD by Z and ML by Z respectively. It is compressive at the top and tensile at the bottom. Here MD represents moment due to dead load and ML represents moment due to live load. And the last figure represents the resultant stress diagram. Moving on to the second concept, strength concept or force concept. In RCC, steel reinforcement takes up the tension and concrete above the neutral axis takes up the compression. A couple is formed due to the resultant compressive force C and tensile force T, so that C is equal to T. This internally formed couple resists the moment due to external forces. The same concept can be applied to pre-stressed concrete sections also. Pre-stressed concrete is considered as a combination of steel and concrete, with steel taking tension T and concrete taking compression C. Thus, the two materials produce a resisting couple which will resist the moment due to external forces. This concept has been well utilized to determine the ultimate moment of resistance of pre-stressed concrete. Now the last concept is load balancing concept, which was developed by Lin. If the external loads acting on a beam causes a sagging curvature to the beam element, any load which introduces the hogging curvature onto the beam equal and opposite in nature to that caused by the external loads is called pre-stressing force, and this method of pre-stressing or preload is recognized as load balancing concept. In this approach, the external loads are treated only as loads and not converted as stresses on the structure. Pre-stressing is also converted as equivalent load, and this equivalent load must counteract to balance the external loads. It is possible to select suitable cable profiles in a pre-stressed concrete member such that the transverse component of the cable force balances the given type of external loads. So, as a whole, we dealt with three concepts: the stress concept, in which the pre-stressed concrete is treated as an elastic material; the strength concept, in which the pre-stressed concrete is considered as reinforced concrete dealing with ultimate strength; and the load balancing concept, by balancing a portion of load on the structure. In the next class, we shall deal with the classification and method of pre-stressing. Thank you.